Now, in this video, we're going to take up one more concept, which is the Poisson's ratio. What is Poisson's ratio? The ratio of lateral strain to the longitudinal strain is constant for a given material. When the material is stressed within elastic limit, and the ratio is called the Poisson's ratio. So that means the ratio of Poisson's ratio, which is denoted by 1 by m or mu or nu, 1 by m will be equal to lateral strain by the longitudinal strain. So what is the volumetric strain? The next one is volumetric strain, the ratio of change in volume to the original volume of the body, which is known as the volumetric strain. That is epsilon V will be equal to change in volume by original volume. So that is delta V by V. So consider a rectangular bar of length L, width B and thickness T is subjected to an axial tensile load. What is the original volume? Length into width into thickness, that will be equal to L into B into T. So when you are taking the change in volume, delta V will be equal to final volume minus original volume. What is final volume? Final volume will be equal to L into B into T plus B into T into delta L plus or minus here, because since it is along the length, it is increasing, and what happens to the lateral dimension? The lateral dimension will decrease, minus of L into T into delta B minus of L into B into delta T minus L into B into T. So as we know, L into B into T and L into B into T, positive and negative will go to get cancels. Therefore, delta V will be equal to B into T into delta L minus of L into T into delta B and minus of L into B into delta T. So what is the volumetric strain? That is delta V by V, which will be equal to ratio, that is B into T into delta L minus of L into T into delta B minus of L into B into delta T. So when you divide each one by this L into B into T, you will going to get it as delta L by L minus delta B by B minus delta T by T. So what is the Poisson's ratio? Well, the Poisson's ratio is, that is lateral strain by the longitudinal strain. What is the lateral strain? 1 by m into the longitudinal strain. So what is that? Lateral strain is delta B by B or delta T by B. Sorry, delta T by T will be equal to 1 by m into delta L by L. That means either it can be delta B by B is equal to 1 by m into delta L by L, or delta T by T will be equal to 1 by m into delta L by L. So where delta L by L is the longitudinal strain and delta B by B or delta T by T will be lateral strain. Therefore, epsilon V will be equal to delta L by L minus 1 by m into delta L by L minus 1 by m into delta L by L. So that is what is epsilon V. So delta B by B is equal to, here we are substituting the value of the volumetric strain epsilon V. So delta L by L minus delta B by B is 1 by m into delta L by L, you substitute that, and minus delta T by T again minus 1 by m into delta L by L. So that will be equal to delta L by L, you take out the common factor, 1 minus of 1 by m into 2, that is delta L by L into 1 minus 2 by m. So now, then the volumetric strain epsilon V will be equal to delta V by V. So longitudinal strain into 1 minus 2 by m is the value. So delta L by L into 1 minus of 2 by m. So therefore, that is epsilon V will be equal to delta V by V. So delta L by L into 1 minus 2 by m. So what is delta L by L, which is epsilon into 1 minus 2 by m, where epsilon is the longitudinal strain, and so that is how you will be able to derive this equation. Now we will going to consider the volumetric strain of a rectangular, or it is a prismatic bar subjected to a single direction load P, or the direction of normal stress. So that is, you have L, B and D where the normal stress is applied along the length of the member, so P or sigma. So this is how you will going to get. So length is along the direction of X, and D is along the direction of Y, and Z is along the direction of B. So now, when you are considering this, consider a rectangular bar of length L, width B, and depth or thickness D is subjected to an axial load P or normal stress in the direction of its length, which is as shown in the figure. So here length L is in X direction, again a thickness depth in Y direction, and the width is in Z direction, which I have already explained. So what is the original volume? Capital V will be equal to L into B into D. So what is delta L will be the change in length, which is increased because the applied load is along the length of the member. So therefore, naturally it will going to be the increase in length. So what is delta B by B? Change in width. So as the length increases, the cross-sectional area of the member will be decreasing. That is, delta B change in width is decreasing, and delta D is change in depth or the thickness, which is decreasing. So differentiating the original volume, what happens? Delta V will be equal to L into B. So B into D into delta L plus L into B into delta D plus D into L into delta B. So now, what is the volumetric strain? Epsilon V will be equal to change in volume by the original volume. So what is delta V by V now? So you substitute the values of delta V and V, B into D into delta L plus L into B into delta D plus L into D into delta B by L into B into D. So that is equal to delta L by L, and then dividing the ratio by each of these expressions, which will be delta V by V and plus delta D by D. So therefore, epsilon V will be equal to epsilon X plus epsilon B, epsilon Y plus epsilon Z. So this is how you will be able to get the volumetric strain. Strain in the direction of load, that is epsilon X, will be equal to sigma by E, because epsilon X is sigma by E. So lateral strain in the direction of YY, which is epsilon Y, will be equal to delta D by D, which is equal to minus 1 by M into epsilon X, which will be equal to minus 1 by M into sigma by E. So similarly, the lateral 1 by M is the lateral strain by the longitudinal strain. Negative sign indicates that it is in decreasing thickness. So similarly, so what is the lateral strain in the direction of ZZ? Epsilon Z will be equal to delta V by V. So that is minus 1 by M into epsilon X. So minus 1 by M into sigma by E. So negative sign indicates that it is the decrease in width. So similarly, epsilon V will be equal to sigma by E minus sigma by M into E minus sigma by M into E. So take out sigma by E is the common factor, 1 minus 1 by 2 by M. So volumetric strain epsilon V will be equal to sigma X by E into 1 minus 2 by M, which is equal to epsilon X into, it is not epsilon X by E, it is epsilon X into 1 minus 2 by M. What is epsilon X? Which will be equal to delta L by L into 1 minus 2 by M. Here E will not be there, it is only epsilon X. So similarly, so volumetric strain of a cylindrical bar is subjected to an axial load P or the normal stress sigma. So that is the single direction. Here we have both Z and Y will be equal to D, and P or sigma will be applied along the direction of X, which is the length. So what happens here? Consider a cylindrical bar of length L and the diameter D is subjected to an axial load P or the normal stress sigma in the direction of length, which is as shown in the figure. So what is the original volume of the bar? Original volume of the bar V will be equal to pi D square by 4 into L. So here differentiating both sides we have delta V will be equal to pi by 4 into D square, pi D square by 4 into delta L plus L into pi by 4 into 2D into delta D. So where delta V is equal to change in volume. So delta L will be equal to change in length and delta D is change in diameter. So therefore, the volumetric strain epsilon V will be equal to delta V by V. So you divide this, substitute the value of delta V as pi d square by 4 into delta L plus pi into L into pi into L into 2D into delta D by 4. Whole thing is divided by pi d square by 4 into L. So therefore, that will be equal to dividing each term with denominator of pi d square by 4 into L. So that is delta L by L and pi d. So here delta D by D, 2 into delta D by D. So once you get that, therefore epsilon y is equal to epsilon z here in this case, which is delta D by D, because you have the diameter, y and z will be equal. So delta D by D. So therefore, epsilon v will be equal to epsilon x plus epsilon y plus epsilon z. So longitudinal strain epsilon x will be equal to delta L by L, which is sigma by E, into lateral strain in the direction of y by epsilon y will be equal to delta D by D, which is minus 1 by m into x epsilon x, minus that is equal to minus 1 by m into sigma by E. So 1 by m will be equal to, that is the lateral strain by the longitudinal end, which is the Poisson's ratio. The negative sign indicates that it is the decrease in diameter. Similarly, lateral strain in the direction of ZZ, which is epsilon z, will be equal to delta D by D minus 1 by m into epsilon x minus 1 by m into sigma by E. Therefore, epsilon B will be equal to sigma by E minus 1 by m into sigma by E minus 1 by m into sigma by E, which is equal to, taking the common factor, which of sigma by E, 1 minus 2 by m. Therefore, volumetric strain epsilon V will be equal to sigma x by E into 1 minus 2 by m, that is equal to epsilon x into 1 minus 2 by m. So that is equal to delta L by L into 1 minus 2 by m. So this is how you will be able to derive the expression for the prismatic bar and also for the volume of by the cylindrical bar. So if you find this video is useful, please subscribe to my channel. Thank you.